Hi, Keith here, and in this short video I'm going to introduce you to R. Now what you're looking at here is not R, it's RStudio. This is what R looks like, and it's very back to basics, and so to get things happening here I have to type commands. Now I can remember some simple ones, like how to do some simple calculations and get some simple values, but doing anything much more than that, and I've got to go off to a list of commands I've got from somewhere else to help me get data in and draw graphs and so on. So this is not very functional for me. Now you'll see the text up here at the top part of the window is the same as what you saw in the R terminal window there. And RStudio is running R behind the scenes, and the results come up here. And RStudio gives us the prompt, but what I type in here will give the same results, but RStudio is taking that and putting it into R and then presenting the results back to me. So RStudio is standing between me and R, helping me out a bit, in some cases a fair bit. Now results from R will come up here in the console, except for graphs, which will come up over here in the plots pane. Now to do anything much I need to have some scripts and some data. So here's something. This is not going to appear as one of the files you can download. This is a file I've been putting together as I play around a bit to do various sorts of things. Now, one of the reasons R is popular and powerful is because people write packages. And a package, let's go over here. A package is a group of functions and procedures for doing particular kinds of analyses. And you can say AD4 there is for doing various kinds of analyses of ecological data. If we scroll right down, VGAN there is a community ecology package. So we'll use the four I've got listed up there, particularly vegan, quite commonly. Now, there's two parts to a package. First, it's got to be installed, and then R has got to be told to use it. So, installing in RStudio goes like this, and then we need to well, that didn't quite. Something is usually when I type in here, there we are. This is what I was looking for. It's taking a while for this to come up. So if I know the name of a particular package, I can start typing it in here, and RStudio will find it on the repository, which is on the web, and install it. So if I wanted to install that, I'm going to go install dependencies. Here means also bring in any packages that Jade itself uses, because some packages use other packages. I'm not going to do that, but you can see I have installed the psych package over here, which I didn't really need to do because it's already been installed, but it was one whose name I knew, and the bits of the package are over in there. And this has not been installed onto my USB because I haven't told it to do that here. If you're running Studio off a USB, you will need to do that. Have a look at the next video on data files to see how to do that. If you're just running off a laptop or a desktop, just let R and RStudio install in their normal way. So once we've installed it, the command library tells R to load up and use that package and its functions. So for this particular demo, I need these packages, and they've been loaded in because I'm back to the command prompt. I also need to get some data. Now, setwd tells R to go to that particular place and use the files that are there. Now, an easier way to do that is set working directory, which I'll illustrate in the next video. And then source loads in some additional functions, and you can see those over here. These are functions written by the people who did numerical ecology with R. And there's another one, which is also required. The text in green is comments. Now, I can't really do very much without some data. So I'm going to execute these two lines here, which will bring in some data. And they read comma-separated files into these two data frames, ENV and SPE. I'll look more at data and so on next one. So this is a set of data from the same simulation you use. Then I'll do that. And I'm not talking about what some of these commands can do. That one does paired plots of one variable against another, so that's why it's called pairs, and that's an example of a graph being produced by R and displayed for us in the plots window where I can save and export. Now, the advantage of R is that people who are better at this than I am can write this stuff, and then all I have to do is run it. And most of what you're looking at here was written by the people who did the book Numerical Ecology with R. And what they're looking at doing here is a particular kind of multivariate analysis called a correspondence analysis. And it's done it, and you see more results are being shown. Those are the functions. Results are coming up here, and results are coming up in the terminal window here, or the console window, for the printout of the analysis. And running in RStudio like this is handy because I can have the result, text results or numerical results over here, and there's a lot of them, as you can see. Now, we may look a little bit at correspondence analysis, but we'll be using other analyses more commonly. And I've got the numerical results over there, and I can put up some plot results over here, and I can change the display of those results by changing things in the script. So the scaling is a particular aspect of the way in which the plot is shown. So you can see here, scaling 1 is on the left, scaling 2 is on the right, and here we've got the taxa showing out large with the sides bunched up, and the reverse over here. So some of those sorts of things we'll look at later on. Now, some simple commands. using RStudio to get rid of the script or to start a new one, I'm clicking up here. So I don't have to get rid of that one. I can load up another one. When I get to my scripts folder, there we go. So here's another bit of script that I've been playing around with. I'm not even going to try to run this because I don't even know it works, but I can have scripts across here. I can have data windows open, and I can flick backwards and forwards between them, and I can run commands out of different scripts. So what I have been doing while I've been playing around and getting things working is I'll have a testing script like this where I'm trying out commands, and I have another script open where I copy in the bits that are working the way I want them to work. I can make that panel bigger so I can more easily look at results if I've got a long string of them, and likewise for the graphs, and the graph will reframe itself to take up the available space if I need to see things a bit larger. Likewise here. Go back to the usual display. So then it's rescaled itself to look better. Getting rid of any of these things is that. Got buttons up here for saving different parts. So saving script files, saving data files. The best way to work is to start a new project when you're starting to do something, and then periodically save the project as you're going along, because everything, the graphs, the results, the commands, the data, everything will be saved, and you can go back and look at it. For instance, if I go into the history over here, there you can see all the commands that I've been putting through as I'm running through doing these analyses and demonstrations. So the power of R really comes from its packages, because we can add in a package for doing just about everything you can think of. And when new methods are being developed and refined, they're nearly always now done as an R package. In fact, and I shouldn't do this because when I do things off the cuff, it always goes wrong. Here is something called QValue. Now, we're not going to look at this during the unit, although I may mention it, but this is a package that has been built in R, using R. Will this work? He wonders. To do some... no. Yep, didn't think it would work. It looked for a minute like it was going to. It's not working because I haven't got all the bits of it there, I think. But it is a package that's been built to do some very special and very sophisticated kinds of analyses that are still being developed as I talk now. Okay, that's where I want to leave it with R, because there isn't really a whole lot else I can add to what I've said there. The main part of learning to work with R will be building up scripts, like this, sets of commands that you can run, and what I'll be doing is providing some of those. So the next video in this series, which is looking at data files, not the next one, the one after that, which looks at summary statistics, comes along with a little package of R commands to do some summary statistics and display some useful graphs.